Alright, so I know it's going to be x and x. What two numbers multiply by 12 add to be 8. Yeah, 2 and 6 are like done.
So it doesn't matter which order they're in that
Doesn't matter.
situation,
Put
right?
6 and 2.
Okay, yeah.
Let's see. So this one, yeah, it's got a negative in there, but it's not really going to affect it that much because the two numbers are going to both be
Negative.
the same sign. If they both be positive, I know they're the same sign, and the middle tells me, oh, they ought to both be negative. So two numbers that multiply by 20 add to be 12, and they're both negative. Right? It's almost the same as this guy. Yeah.
10 and 2.
Yeah, 10 and 2, make them both negative. And how do you always check any of these? You just multiply that sucker back out. Distribute that stuff back, make sure it becomes that. Or, you could do that weird stuff we did before. Let's do one real quick. This is done. On the side, if x were, what, Jeff? If x was, oh, you're going to let me put, well, no, let's make it like 6. If x is 6, then what number is this? It would be 6 squared. This would be 36 minus 72 plus 20. Negative 36 plus 20. That number is negative 16. Is everybody with me? Where did the shit did 6 come from? I picked it, because what could x be? Anything. So I just chose 6. You could choose 7. You could even speak correctly instead of say chose. It's up to you, though. If x is 6, what number is this? 6 minus 10. Negative 4. If x is 6, what number is this? 4. What's negative 4 times 4? So this is a way to factor whatever number that represents. So a concrete way to check is to make x a concrete value. See what number it starts off as and compare it to these numbers you get at the end. I guess you don't ever have to do that if you don't want to, but you can. And that's the concrete idea behind what we're doing. Just make sure everybody really understands. Everything in red is extra. You never have to do all the stuff in red. Hopefully some of you guys will. It's kind of neat. This one, I think, turned a few of us off. Yes?
Negative 15 and 4.
Yes. And that's not, when I say 60, that's not the first thing. You're not going to go, oh yeah, that's 5 times 14. Right? Or 4 times 15. Right? You think 3 and 20, you think 2 and 30. So me, I would go, either you make a big list of 60 factors, right? 2 times 30, 3 times 20, 4 times 15, blah, blah, blah. Or you can even do the whole 11 apart stuff, right? And I don't know if I'm going to have a lot of people that buy into that, but like 13 and 2, they're 11 apart, right? And if we make the 13 negative, it makes negative 11, right? But it don't multiply by 60, it's too small. So let me step it up, maybe negative 15 and 4. What's negative 15 times 4?
Negative 60.
Negative 60, kick ass. So it'll be x minus 15, x plus 4, or the other way around. Okay, you guys doing all right? You never have to do this either if you don't want to. You can just take 60 and start making a list of factors until you hit the two that also make that happen, right? In this case, one of them's got to be negative, right? You guys with me? There's always kind of multiple ways to do this. Oh yeah, this one. Everybody enjoyed this one. This one's not too hard to kind of like trial and error it out directly, but we really have only learned how to handle it when there's no number here. In fact, I don't know if you noticed at the very top where it says factoring x squared plus bx, it's got to be an x squared first for this process to work directly. So thank God, what can I do with 2?
Take it out.
Take a 2 out. So now the 2 is just going to kind of come for the ride. So for example, if I say factor 980 completely, one thing you can do immediately is go 10 times 98, right? And then keep going, and the 10 just kind of comes for the ride, and you eventually make that 2 times 5. So you take care of a piece of it. I took care of the 2 piece. It's just going to keep coming for the ride, and then this has got to get broken apart next. So then, of course, this is going to be kind of nifty.
X plus 2.
Yeah. 2 adds to be 2, and 2 multiply to be, sorry. 2 2's add to be 4, and 2 2's multiply to be 4. It's kind of neat. So this is right. What's another way I can write this, though? Yeah. So either way like that. I like it. Let's see. E's got negatives all over the place. Let's see. So everybody got this here? I like it. I want you to realize when the middle number is a 1, that's nice. I need 2 numbers that are 1 apart that make 72. So then, even if you don't know your times tables too well, you go, well, 7 and 8 are 1 apart. They multiply to be 56. Not quite 72. So what about 8 and 9? And which one's going to be negative? The bigger one, so that an answer comes out to be negative when I combine them. So this is going to be a plus 8, a minus 9. Jeff, man, I desperately need this spring break, I tell you that. Oh, man.
We all do.
Yes. As much as you need it, the teachers need it too.
Thanks.
Let's see. Is that cool? Okay. And then F, this is probably everybody hated this one. The minute you find out the answer sometimes could be prime, I'll do a test and like somebody gives it and like 7 of them they just put prime. No. In the homework there might be a couple that are prime. So if you're answering prime 8 times, you are wrong, right? So this is prime because the only way to factor 7, really, with whole numbers, thank God we're not going to use fractions or shit, right? I appreciate the attempt, but I'm not going to make you do that. This is all whole numbers. It's 7 and 1, and they ain't never going to make 3. So, no, this is just, you just say prime, or you say can't be factored, that's fine too. Right. Don't just leave it blank, because then I'm going to have to assume you have no idea. You better put something, right? Okay, I like it. So, what else is here? All right. I want to lay just a little groundwork, and then I'm going to let us out early. I was going to have a whole other worksheet, but I think that's fine. You guys okay with that?
Yeah.
And then tomorrow we can do that other worksheet. All right. Because we're actually doing pretty good. We're a little ahead of the game, to be honest. So here's a little bit of groundwork for what we're going to get into next. If I had to figure out, why can't I currently figure out how to factor this? What's the main thing that I can't do anything about? There's a stupid 4. Just like there was a stupid 2 in that one problem. So what did we do? We took the 2 out. Can I take a 4 out?
No.
Shit. But, not surprisingly, this next worksheet is going to look a lot like, and actually you already have it. It's on the other side of that one if you dare to look forward. But what we do is we take examples, not like x plus 5, x plus 4. We take examples like 3x plus 5. 2, let's make this nothing that goes into 4. 5x plus 4. Because those 2 would multiply by a number in front that's not 1. All right, so here's just, I'm just going to lay some basic groundwork. 3x times 5x is 3x times 4, 12x, 25x, 20. Now, notice a few things. Let's see. Everybody cool with that?
Mm-hmm.
Cool. And I was double checking as I was turning around because I don't trust myself today. All right. Couple things to realize. Is this, before this middle number always was the sum of this and this. Is 37 the sum of 5 and 4? No. Can you guys see what messed that up? The parts of 15, the 3 and the 5, messed that all up. Because instead of having 5x, I had 25x. Right? Whereas if that wasn't there, if that was a 1 and a 1, that's why those are easier. I don't have some other numbers that come in and mess everything up. Are you guys with me? So I have to know that this method is going to be a little harder because there's more shit to worry about. Right? But it's still not going to be insanely hard. So there's a couple things I want you to realize. We have to really work on this pattern, but this is really kind of cool. What is 15 times 20? Quick way to do that is, what's twice 15?
30.
Times 10. So I took 20 and made it 2 times 10, so I can bring the 10 in at the end. So that's 300. What's 12 times 25? 300, right? And of course 12 is 4 times 3. 4 quarters is 100 times the other 3 is 300. That will always be true. So what we're going to do, so let's do one more of these, and then I'll talk about what we're going to do. Let's see if that pattern, that idea holds, that these two multiply the same as these two. That's going to give me, if I start here, the first thing I'm going to do is multiply these two together to see what number to kind of work with. We got to then fill in what the next step is, but I'm hoping at least that step makes, that's the number that kind of matches what's going to happen in the middle. Maybe. So let's do another one of these. Here, I can't do you yet. Get out. So let's do, what you got, Jeff? 2x minus 5, 4x plus 3. So let's see what we get. X squared, 6x, minus 20x, minus 15. So I get 8x squared minus 14x. So what's going to happen, of course, in chapter 6 is they're going to give me this, and I have to work this way. Well, let's check to see if that same thing happens. And if it does, it's a reasonable assumption to say it always happens. We could do a few more of these to make sure. And to be honest, well, I don't know if I want to do this. So what's 8 times negative 15? The first times the last.
120. 120.
Yeah, negative 120. And what is 6 times negative 20? Well, that's a little easier. That is also
Negative 120.
negative 120. Interesting. And again, the first people to kind of realize this had to just do a few to see the pattern, or they were doing all this work and they said, does that always happen? It seems to always happen. How would you prove this? That's what I was just thinking to myself, if I want to do this with you guys. You would put ax plus b times cx plus d. No numbers in there. That's really interesting. That's how you prove something, because everything we're doing is dependent on the numbers, it seems. Maybe. You guys are actually more on that than I thought. I don't mean to say anything. So watch. This might actually help. Well, anyway. Yeah. I don't know if you guys want to suffer through this. But acx squared plus adx plus bcx plus bd. All right, isn't that gross? But it's not that horrible, right? In fact, it's kind of nice. I got nothing I can put together. What is AC times BD? ACBD. And what is AD times BC? ADBC. Are these the same thing? Yes, so that's a proof. That's the proof. Because it works for any numbers, because A, B, C, D represents any numbers. So this pattern we saw with the two middle dudes multiplied by the same thing that the outer dudes do is just always true. So next time we'll work on the whole process, how to use that. Okay, that's nice. How does that help me? So I have to finish that out tomorrow.
So in a problem where we're given that, the answer would be what you did underneath? Like this?
Yeah, if I was given this problem, the answer would be this.
No, but what if we're given the top part, then the answer is the underline? That's what I'm asking.
Yeah, but that was chapter 5,
Well,
right?
I'm just looking at the back.
Yeah, totally. So
So
just,
the answer
yeah, I
would
start you off with a few of these
Yeah.
just to see the motivation. Yes. So we're going to work on that worksheet tomorrow. Okay. I'm going to go do something. Like that. We need a found 2 spring breaks. We got one. Hold on. All right, guys. I'll see you tomorrow. Only 1 week. Yeah. Oh, okay, so it's not multiply. Here's what this means. See, G by themselves don't actually mean, it's gotta be F of, so it's really, what this means is F of 3 minus G, which is kind of like a more compact way of writing. It's like, subtract the function values of 3. Well, here's a better way to write it. Okay.
$1 an hour? Rate calculator?
I have homework.